Time to divide some fractions. Dividing rational expressions. Rational expressions just means fractions that have polynomials in the top and the bottom. But we divide these fractions the same way we divided our other fractions, which is keep, change, flip. So division, we always do keep the first fraction, change to multiplication, and then flip the second fraction. Always flip only the second fraction, never the first one. All right, so let's try that. So anytime we see that divide in the middle, we're gonna keep the first fraction, x squared minus 2x minus 8 divided by x squared minus 9, change to multiplication, and then flip the second fraction. So x plus 3 is now on top, x minus 4 is on the bottom. Now before we start crossing things out, it has to be factored. So next step is to factor. Good news is x plus 3 and x minus 4 don't factor any further. That's as simplified as they can be. But we can definitely simplify or factor this first fraction. So we're looking for two numbers that multiply to -8 and add to -2. Well, and feel free to write out more work for yourself if you need it, but I'm hoping we're at the point now like, oh, well, 4 times 2 makes 8. If I make the 4 negative, then it would add to -2. Right, and FOIL's a good way to check that. The bottom is a difference of two squares. So just x minus 3 times x plus 3. And now the second fraction, I just leave it in its flipped form. Oh, except write it correctly. That would help. Especially because we want that x minus 4 to cancel. So now x minus 4, there's one of those factors on the top and bottom, so they reduce. We can divide by them. X plus 3, same thing. Those cancel. So what's left behind is x plus 2 on the top, x minus 3 on the bottom, but now we have our domain restrictions. So usually we just put like a comma here, and then we list what x cannot equal based on the factors that just canceled. So the first factor that canceled, x can't equal 4, because that would make these 0. This factor, I can't have x be -3. And the other thing we want to check is the original problem, especially because we flipped that second fraction. So if you look at the original problem, we want to check that those can't equal 0 either. So in this case, after we flipped this, the x plus 3 canceled. So it's not going to add an additional one. But one thing we might want to do is just sort of verify and say, oh, maybe we shouldn't have x equal 3 either. So we want to check the original problem and make sure we're not going to be dividing by 0. No zeros in the bottom of the fraction. And so in this case, 3 is also a restricted domain. So I'm just going to list it, even though it's part of this here, we're going to list it too. All right, so factors that cancel and double check that the original problem can't divide by 0. Let's try the next one. Simplify and then write any domain restrictions. All right, first step, for divide, I need to do keep, change, flip. So even before I start factoring, or you can, flip and factor in the same step if you're up for that, I'm going to just do the flipping. So I'm going to keep the first fraction, x squared plus 4x over x squared minus 25, change to multiply, and then flip the second fraction, x squared minus 6x plus 5 on the top, and now x squared minus 16 on the bottom. All right, now it's time to factor. Before we can cancel, we have to factor. The top, this is not a difference of squares. It has a GCF of x. So if I factor out an x, what's left behind is x plus 4. So that's the same as x squared plus 4x. The denominator is is a difference of two squares, x minus 5 times x plus 5. The denominator of the second fraction after I flip it is also a difference of two squares. So let's do that. X minus 4 times x plus 4. It's the top that's a little tougher. We need to multiply to 5 and add to negative 6. Well, the only numbers that multiply to 5 are 1 and 5. Or I guess there's another option, negative 1 and negative 5. Also multiply to positive 5, but this time they would add to negative 6. So that's what we need in the top. X minus 1 times x minus 5. All right, let's see what cancels. The x plus 4s cancel. They match. The x minus 5s cancel. There's one on top, one on bottom. And I think that's it. So what's left behind is that x on top and then times x minus 1 divided by, and what's left on the bottom is x plus 5 times x minus 4. Always keep denominators factored. And really you can keep the numerator factored as well. There's never, I don't know if, like, I can't think of any reason why we would want to multiply out a denominator. Numerators, what we're going to see in the next section is we might need to multiply them out to add or subtract fractions. But we always want to keep denominators factored. And if there's nothing else we need to do, we may as well keep the top factored as well. Now, domain restrictions. X cannot equal what we canceled out these x minus 5, so that's cannot equal 5. We canceled x plus 4, so that's a negative 4 would make that 0. And then we want to double check that the original problem can't divide by 0. So I'm just going to rewrite the factoring we already did. So we cannot have x be 5 or negative 5. Those two would make the first fraction divide by 0. And then in the second fraction, that factored to x minus 1 times x minus 5. So we have the 5 already, but there's this additional 1 that has to be in that restricted domain because before we flipped, that would make the original problem divide by 0.